Hello and welcome to another video. In this video we're going to be continuing on with the zero track list, and so I think I'm on this one here. So it looks like there's 30 pages left. I probably did about half of those. But yeah, definitely these problems none of them are too easy, none of them are too hard, so definitely kind of like a good place to practice. Okay. And then I also made a list that's kind of helpful, and I'll probably make like a video on like everything I'm doing here to get a little bit better, where I just list like the problems, the ratings, how long I took, some notes, should I redo it, things like that. Okay, so let's get started here. So let's see, maximum fruit harvested after most case steps. Fruits available. Okay, 2D integer array fruits. Amount fruits. Sorted by position. Each position is unique. You're given integer start position, integer k. You're at the start position. You can go left or right. It takes one step to move one unit. You can move k total. Every position harvests all the fruits in that position. Okay, so there's these fruits like that are sorted, I guess. Yeah, sorted. And you start at some random space. And you have a number of steps you can make. And then let's see. Yeah, and then you just figure out like what's the best. So here you have 4 steps, so you just go collect all these, and then you can't really go back and get the others. Okay. Here you have 4 steps as well. Okay, so you go here, come back, and then get all these. Got it. Okay. Optimal way. Okay. Here 2, so you can't reach anything? Yeah, okay. Alright. So I think I can kind of get like what's the optimal thing to do. Just going to be the implementation details. It's going to be a little bit tricky, but essentially, if you have fruits on both sides, you're going to want to do one of a couple things. You're either going to want to like go left and either stop, or go left and come back, then go right. So basically, like you're going to start here, you're going to go left to some fruit, then you're going to come back and go right as far as you can. Or you will go right, then come back and go as far as you can. And I think this is the only optimal thing, because if you want to collect fruits on one side, you would just go left like as far as you can, and then you would just not turn around. Go right, same thing. But if you do want to get like X amount of fruits, like let's say you want to go from here to X amount of fruits, you wouldn't want to like go back and forth, right? So the optimal is just go left as far as you can and then go right as far as you can from there. Yeah. And then same thing for the other one. So how do we do that efficiently? And the fruit's length is 10 to the 5th. Yes, because these fruits are sorted, I think what we're gonna want to do is we're gonna want to like start like let's say these fruits are on a number line of like 0, 2, 4, 6, 8, 10 or something, and we start at like position 5. I think we're just gonna go left to each fruit and see like can we even reach it, right? So from here, can we reach? Let's say k is like let's say start is 5, k is like 6 or something. So we're going to say, like, can we reach this? And if we can, then we're going to say this is our left stopping point. Now let's go right as far as we can. So we're going to say, okay, we reached this one, and now we have 5 more steps. So what's the farthest fruit we can reach? And then we'll do like some kind of total. And then we're going to say, okay, now let's see what happens if we try to reach this one. If we can, what's the farthest we can reach, right? And so on. Yeah. And how would we want to do that? I mean, we can pre-calculate actually. So we can just make an array of like, okay, for this fruit, like how many fruit can we go to the right? We could also binary search it. I think either one's fine. So now, then we have to also calculate like how many fruit did we actually get, right? So like, yeah, I think we can pre-calculate. So for every fruit, we can say like, okay, if this is the left one, what would be the right? So what would that look like? So that would look like, you know, let's see, we'd have 2 pointers, and we'd say, okay, well, first of all, we only care about fruit that are reachable, right? So every other one we can just get rid of. So if it's too far to the left or too far to the right, like we can get rid of all of that. So we can clean that up a little bit. So basically what we would do there is we would say like, okay, so if we start at 5 or k is 6, so we can go at most to 0 or to, I guess here everything's reachable. Yeah. So we'd leave the whole thing as this. But let's say it wasn't, we would just get rid of fruits we can never reach to make it simpler. So I guess step 1, like, get rid of fruits that we can't reach at all. And you can probably do all this with like one space, but I'm not going to do that. I think we can just make a linear time solution and just make some helpful stuff. Okay, so then, yeah, basically we'll say like, okay, so for this fruit here, or actually, no, so for this fruit, we took 5 steps. So what's the most we can reach? And we can just use 2 pointers here. So like for this fruit, this would be the biggest. Actually, we can't reach anything, right? Because we only have 1 steps. So it would just be, this would be the right pointer, actually. Then for this fruit, now we took, how many steps? We took 3 steps. So we have 2 more. So now this would be the right pointer. And then for this fruit, we took 1 step. So now we have 5 more. So this would be the right pointer, and so on. And so we can do that for every single one on the left side. And yeah. And then obviously like the right pointer can be out of bounds as well. And then we could do the same for the right. But that means we're like going somewhere, going back, and then stopping. Is there ever another case? No, I don't think so. Yeah, so we can essentially calculate this. So what this will look like is like here, and we can just have indices, right? All we need is indices, and then that'll tell us like, do we need indices or do we need? Yeah, probably the index, I guess, and that'll tell us like how many we can get if we go left here. Like if this is index, like I think we'd want format of like maybe index and then the index we can reach or something like that, or just total number of fruit we can reach if this is our thing. So actually we can, now I'm thinking about it, we can just calculate this on the fly. Yeah, so we can just, instead of even storing this, like we can just calculate it on the fly. So we can say like, okay, so when we reach this, like we'll start here and we'll say like, is this reachable? If it's not, we'll just keep moving this up until we have something reachable. And then from here, basically we're going to say like, okay, so we can go from 0 and then we have 1 more step to the right. So we can't, so this is the only one. So the result will be like 1 here. And then here the result will be like 2 and so on. So we can calculate it on the fly going left to right, and then we can calculate it on the fly going right to left. And then we just get the total there. And I think that's it. So actually this would be yeah, basically of 1 space. Yeah. Okay. All right. So let's do that. So, okay, so we're gonna go, yeah, so we don't really care about this. I guess this is fine. So we're just gonna start left, go left to right, to right, with 2 pointer. Then go right to left with 2 pointer. Okay, cool. So we'll start 0. So we'll go for x, y, or for like index, count in fruits. Okay, so this is left to right. So we're gonna say if we're past the starting position, we just won't count it. So if I is greater than start position, we'll just break because we can only go left to right here. All right. And then yeah, so we're gonna want, a j as well. It'll just be 0 for now. Okay, so if start position minus I, yeah, so start position minus I is not, like, we don't have enough steps. So if we go from like 5 to 1, how many steps? We need 4, right? So if this is greater than k, then we can't do this. And then we'll just make j like the next one. So j equals I plus 1. Okay. Now if this is doable, so essentially everything we can't start, we'll just reset our right pointer. Okay, now we basically need to do like how many steps remaining we have. So steps remaining. So actually, I think the right pointer needs to start at the start position. Oh, but we don't know where we're at, right? Yeah, so we are going to need to like calculate it. Yeah. Okay. So I guess what we need to do is so what we actually need to start the j at is the fruit after the right position, the start position. We could do that in a binary search, but we can do that in a while loop. We're only doing it once, so that's fine. So we can just say j equals 0 while fruits j, let's see, is less than or equal to, and maybe we'll go right 0. Yeah, that's fine too. Is less than start position j plus 1, and also j plus 1. J is equal to length. There might not be any, right? So fruit and this one, I think. Actually, it's fine to be out of bounds, but we don't want to. No, actually, we don't want to be completely out of bounds ever. So in that case, actually, yeah, I think out of bounds is fine. Okay, so if we're out of bounds, we can just collect them all. Yeah, that's fine. Or we can do, no, actually, let's always leave it on the last one. I think that's better. And then, yeah, okay. So let's do this. All right, so then steps remaining is start position minus, let's see, start position minus k, I guess. Okay, and so if we can travel more to the right, we will. So if, or while, I guess we can have a while here. So while j is less than length, fruits minus 1 as well. And fruits j plus 1. Oh yeah, I just realized, so this has two things, right? So this is 0. Okay, so fruits j plus 1, 0. Minus start position. Or actually, will this be start position? Steps remaining. No, it won't be start position because we'd have to go to the fruit we picked. So I think this would be I. Yeah, we have to go all the way across. Is less than or equal to steps remaining. Something like this. Okay, so let's just double check. So if I is start position, if this is, yeah, I don't think we need this anymore. So steps remaining, start position minus k. Actually, what we do need to do is we need to do, if start position minus I is greater than k, we can't get this one, so we'll just skip. Okay. So steps remaining equals start position minus k, while j is less than length fruits minus 1. Actually, it would be, yeah, and fruits j plus 1, 0 minus I equals, yeah, so we're really able to take this one. Then j plus equals 1. Okay, yeah. So this will tell us like how many fruit we can take. So the j is going to be the rightmost fruit. The other one's going to be the leftmost. We just do a difference there. So res equals max res. And this is like, right, this is basically like a 2-pointer. So this is just like j minus I plus 1. All right. Now we kind of do the opposite. So we're essentially just going to copy this. Not the best, but it's fine. We're going to copy this and then go the other way. So let's actually make sure for here, like if we can only go left and then turn around, we're getting the right thing. Which I think, so example 2 should be correct. Yeah, I guess. Okay, it looks like it's not. Yeah, so example 1, we can't do this, so this will never, but here. So here we would take like 1 step, and then we'd say, okay, we have 3 steps remaining, so we should be able to get all these, and then this is 4. Oh, right, we're not I see. So there's another thing that I'm missing, which is, so these fruits have like not a count of 1. So I think we can just prefix them that. Yeah. So, yeah, that's fine. So for, I guess, I, and then we don't care about this value, so we'll just do this. Fruits, fruits, I equals fruits I minus 1, plus, this is not fruits, this is prefix sums. I definitely want to be able to like do these harder ones faster, but I feel like I did like think about it for a while, so that's fine. Okay, so here, this is no longer this is prefix sums. J. This. Minus. What are we getting now? We're getting a 0. Interesting. Did I just miscalculate? Let's print it. Negative 1 0 0 8. Yes, it looks correct. Yeah, it looks correct. Okay. So res prefix sums j minus prefix sums. Yeah, so I is the leftmost one we can take. Okay. Let's also print I and j, I guess. Just make sure we're like doing the right thing. I and j. Okay, so I is 2. How's I 2? Oh, because this count is not correct, right? I'm not even using it. Okay. In that case. Fine. Oh, I see. Actually, no, this was correct. This is, oh, yeah, I see what I'm doing wrong. Okay, so yeah, I need to slightly change this. So basically, like, we need to know what index we're at now, and we're never keeping track of that. So yeah, so let's fix that. Range. We don't really care about the count anymore because we have that separate, but we do need to actually calculate like this one, and this is what we need to use. So the location steps remaining, while j is legs and fruits, j minus 1 0 minus location. Okay, so j is that correct? Fruits j 0. Yeah, so j is the actual fruit we're on. Right. Okay, so this should be j, but this should not be, or this should be I. So what are we using the lock for? Oh, just the, okay. Yeah, let's try that. Are we getting something now? Let's see. So for I equals 1, we're getting 2. Why are we not doing I equals 0? Yeah, like why? Oh, this is example 2. Whoops. Yeah, so there should be 4 like fruits here. So for I equals 0, or okay, I equals 1, j equals 2, 3, 4. And this is 2 for some reason. So we have 4 steps. This is 1, 2, 3, 4. Yeah. For example, let's print j here just to see like where are we. Yeah, and let's get rid of all these other test cases. Yeah, this is definitely taking like significantly longer, but this is fine, I think. Okay, so j is 2 to start off, which is fine. Okay, so then the location is going to be fruits I0, which is this one, so 1. And then while start position minus location is greater than k, that's not true. Steps remaining, start position minus 1. Okay, that's true. Oh wait, start position minus k. No, right? Yeah, definitely not. Yeah, so that was a mistake. Okay, so this is location, I think. So now, okay, the prefix sums is fine, so we can just toss that. J is fine too. Okay, so now we can see. Okay, so for I equals 1, j equals 2, which is not correct still. So let's print this. Alright, so steps remaining is 1. What? Start position minus location. Oh, right, I see. So actually, okay, so it's k my, god, this is pretty bad. Okay, so if this is greater than k, steps remaining is this though. Now I think, nice. All right, so that one's done. Now we just need to go for the reverse. So we can just copy paste to save some time. Yeah. So we'll just do this again. Okay, so yeah, and then we'll look at some cleanup. Okay, so j here is going to be 0, not 0. I guess like length fruits minus 1 or something. And then we basically just do the opposite. So while j is greater than 0, and fruits I minus 1j is greater than, then we'll do subtract. So here we'll do backwards. I mean, it's pretty hard to actually simplify it, but yeah, into 1. So location equals fruits I0 if location is greater. Okay, so now it's less. If start position minus location. Okay, so now it's location minus start position. Steps remaining equals location minus start position. And then while j is, so this is the opposite, so this is greater than 0. And then fruits I j minus log. So j is to the left now. So this would basically just be the opposite, right? So we're going right then left, so this way. Minus 1. Minus 1. And now, so I is where we're ending. And j is the original. So like this. Okay, let's try to submit. I don't know why I reset that actually. Okay, we'll keep running. Let's see if it works on the original test cases actually, before we do anything. Okay, so it doesn't work on this first one. Okay. We got 17. Interesting. So for this first one, basically like we know we have to go right, so let's just completely get rid of all this and see if we get the same. Because like this should just be our answer. Okay, we're still getting 17. So it's definitely just good to isolate that. Okay, so while j is greater than 0 and j is less than start position j minus 1 because we want to go left afterwards. Yeah, makes sense. Okay. Now, what if everything is bigger? I guess we'll figure it out. Like, what if we're to the left of everything? I mean, then we can just like, I don't know, let's see if this holds up. But anyway, okay. So for I, okay, so yeah, we're going backwards. Location. If location is less than starting position, we break. If location minus starting position is greater than k, then we can't reach it. Yeah. Steps remaining. Okay. While j, okay, I see. So j is actually over here. But we can't reach it. I think that's what's going on, which we should handle. I mean, I guess we could check for that. Maybe we're missing that. So like j can technically be out of bounds. Like if j is here, it can technically be out of bounds. So I guess we can do a let's see. Then what would be, yeah, like if we can only go right, maybe we actually want to start the j over here, because that would always work. So instead of starting the j like this, we actually want it to be the first thing that's to the right. Yeah, I think that's more correct. So how do we fix that? And then here, yeah, so let's just fix that and let's fix the other one. Because like we can't go back, like we can't reach it. I mean, the alternative is we can check it for if we can't reach it as well. That would also work. And if that's the case, we would just only take the right side. Yeah, I guess we could just do that. And that would, okay, so if, let's see, location minus this, wherever j is greater than steps remaining, then we'll just do a, oh yeah, actually, yeah, the reason it won't work is because we don't know like how much is to the right. Yeah, so I think it will be simpler to actually just have j be the first thing to the right of start position. So we can just start it at 0 and then just keep going right. So while j is less than length fruits minus 1, and then this won't run, yeah, this won't run ever if there's nothing to the right. So if j and fruits j is less than, we'll just do a plus here actually. Let's see if we fixed it. Okay, so we did. So now we just got to fix the other one, kind of do the same thing. So here we want the opposite. And so we want the first one to the left. So while j is greater than 0 and fruits greater, we'll do minus. Okay. 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 So that was, I want to say around 27 minutes. It's definitely a lot here. Took me a while to like it's just kind of annoying coding, I guess. And we did actually manage to do it. Oh yes, I guess we couldn't do it in O of 1 space because we have to do the prefix sums. Like I don't think, and maybe there's a way around that as well, but the code just gets kind of messy. So I feel like it's just better to do n space, maybe even have more stuff and clean this up even more. But yeah, so this would be like n and n, and it's kind of easy to figure out right away like what you have to do, but then coding and like getting all these edge cases is not the easiest. So yeah, let's look at some solutions. This is probably like way cleaner. Sliding window, interesting. Okay, so yeah, way less code. All right. Binary search, you need a custom comparator. Yeah, I mean, sliding window also makes sense because essentially like this 2-pointer is a sliding window, so you can just say like, okay, we have a sliding window. The left will be like the left fruit we can reach, and then the right will be the right fruit we can reach, and then we can just calculate on the fly. that makes more sense. That would definitely be cleaner. Let's see what that looks like. You can just say like, let's see, click, what's it called? Clean this up. Yeah, so that definitely would have been easier. Okay, this is still a mess, so yeah. Let's ask it to make a sliding window actually. Turn this into sliding window. Yeah, and so the way to do the sliding window would basically be like, we start at the left fruit, we just traverse left to right, and then, or actually, let's see. Yeah, I mean, sliding window can be either direction, right? We start at the left fruit, we traverse left to right, and we just like move these pointers along. I mean, it's kind of similar to what we did. Yeah, let's see. Okay, for right. Oh, did it really only go one way? Oh, it did. Interesting. Okay, so definitely want to take a look at that. And length fruits, total, max fruits. Okay, for right, total. Okay, so we're saying this is the right side. Calculate the minimum steps to visit all fruits. Oh, so it's just trying everything, I see. So it's saying like, okay, try everything, right? So try going left and then go right. Try going, oh, it's two directions, right? Left and then go right, and then try going right and then go left. Okay, interesting. While left is less than or equal to right. Wait, what? It catches up all of them? Is this like n squared? Hey, unless I'm missing something? Am I missing something? N? Okay, let me read it again. So while left is less than or equal to right. Do we bring up the n? We do. Okay. So while left is less than or equal to right. Okay, that makes sense now. So left position, right position. Okay, if distance is greater than k. I see, so distance, so it does both, and it figures out like if one of them is viable. And if one of them is viable, then like the window is viable. I see, that's pretty clever actually. Okay, so you try both, you figure out like which one is viable, and if one of them is viable, you make it. Otherwise, you shrink the window. And then the window is just the left, like you just keep running count, then you don't even need prefix sums. Okay, yeah, definitely didn't think of that. But it makes a lot of sense. Yeah, so essentially you just have a left and right, you calculate both, and then from there you just calculate. You don't even do this. Yeah, you literally just compare to k. Yeah, this is like way simpler. So gonna be good to know in the future. Yeah, it's definitely way cleaner code. Yeah, I do feel like like these kinds of problems are more just implementation details. So if you can think of like this is like a very clean solution, and makes a lot of sense. So probably just gonna mark this one as like a redo with a sliding. I mean, to be honest, it's pretty easy to like now that I've seen it to like know how to redo with the sliding window. But definitely for these harder ones, writing clean code gets harder and harder and harder. So definitely gonna be something to work on. But yeah, I'm gonna call it there. So thanks for watching and see you next one.